there is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
There are many misconceptions about evolution floating around out there these days. I've touched on some of them in the past, and in this episode I'm going to do so again. Now, since I can't tackle them all, there's simply too many, I'm going to tackle a couple. But today will be a little different. Well, actually a lot different. For help with this, I'm going to turn to the experts. And luckily I happen to know one, a very good one. Her name is Stephanie Keep.
I am Stephanie Keep, and I work for the National Center for Science Education.
It's been around since 1981, and one of its primary goals
is dedicated to getting teachers to be able to teach just science in their science classrooms. And I also work on developing curriculum materials to help educators cover these topics better. And I'm a runaway academic. I consider myself sort of part academic and part educator, but not really 100% of either.
I'm not telling you anything new here to say that Charles Darwin came up with the theory of evolution by natural selection. Now, he wasn't alone in this. If you've been listening to the show from the very beginning, you might remember that Alfred Russel Wallace came to the same conclusion that Darwin did at roughly the same time. It was when Wallace reached out to Darwin for his advice and help that Darwin realized he needed to wrap up his research, complete the book he was planning, and get it out there for the public to read. That book, of course, is On the Origin of Species. And I'm also not telling you anything new to say that it changed the world, and it continues to change the world. It's read widely today, over 150 years later, but for those who haven't read it, and that's a lot of folks, there remains a bit of confusion, specifically when it comes to evolution and natural selection. Most people think, or many people think, that they are the same thing.
They are not.
So, let's put it this way. If you were to ask 9 out of 10 people what Charles Darwin, what his main contribution to science is, you probably hear many people say, well, he came up with the theory of evolution.
Right. It's tough, because his name is so important, and obviously he's kind of synonymous with evolution. His contribution was coming up with the mechanism, a mechanism, not even the mechanism, but a mechanism of evolution.
And that's the distinction. Charles Darwin struggled with an explanation for why organisms evolve. And he wasn't the first one to come up with evolution to explain life on Earth. In his days, it was called transmutation. Many thinkers before him tackled the subject in their lectures and their writing. His own grandfather, Erasmus, also wrote about the transmutation of species in his book Zoonomia, and there were many others.
What started to change, again, with these earlier people like Buffon, Darwin, and then Lamarck and Cuvier, was trying to come up with an explanation for the fact that things changed, that living things had changed over time.
So in 1859, Charles Darwin published his book, and in it he identified natural selection as being the driver behind evolution. Nature is the director and the producer of the grand stage play called life, all life, from the smallest microbial organism to you and I. Now, if you want to extend the analogy, you could call nature a deaf and blind director who haphazardly hands out parts and cuts scenes at will. The past is littered with discarded roles and unfinished lines. Charles Darwin identified the director, and ever since then, he's also been identified as being the author of the play itself, the play that we know as evolution. Now, the thing is, Darwin's director, or natural selection, has been confused with being the same thing as the play. But so what? Why not just go with it?
There's a real problem in thinking that everything is natural selection, because that makes you think that everything you see is an adaptation.
And that's just it. I even have to admit to making this mistake myself. When I think about evolution, I also think about adaptation. And often when I explain evolution, I use Darwin's theory. Although I know the difference, and depending on who I'm talking to, I'm guilty at times of perpetuating the myth that evolution and natural selection are the same thing. It's because it's an easy thing to do, natural selection being one of the key drivers. And notice I said one of the key drivers. Now we'll get to that in a moment. The point here is that natural selection is not evolution.
Not everything is an adaptation. Evolution has been acting, and yes, every creature you see is the product of evolution, but it's not evolution all by natural selection.
So what exactly are we talking about when we talk about evolution? There has to be a better way of explaining it. So fortunately for me, I have Stephanie here to set the record straight.
When you're talking about evolution, you're talking about a change in allele frequencies over generations.
A few episodes ago, we looked at Mendel and his peas. There were peas with green seeds and there were peas with yellow seeds. Some had smooth skin and some were wrinkled. Now, although he didn't know it at the time, what he was looking at when he compared his peas to one another were different alleles.
So alleles are different versions of a gene. Blood type is pretty easy to understand. It's a pretty simple system. There's 3 different alleles. There's 3 different variants of the blood type gene, A, B, and O.
I happen to be O negative for anyone keeping score.
So an allele is just a different version of a gene. Genes, of course, are what code for the physical traits that we see in an organism, which is what what natural selection, I should say, works off of. And frequency is how often those things appear. So, you imagine you've got 100 frogs living in Podville and 50 of them are blue, they've got a certain kind of allele, and 50 of them are green, they've got the other kind of allele. And as those proportions shift, that's when you get evolution.
Now, did you catch that? Frogs and Podville? Now, if you go all the way back to episode 38 on genetic drift, you'll remember the Great Podville Fire of 2015. A fictional fire, of course, where no one was actually hurt, except for a few fictional frogs. So as Stephanie explained, we have changes in allele frequencies over generations. There are 2 alleles in our simplified example in each of the frogs that provide for the color of blue and another 2 that provide for green. Eventually, over time, you will see the dominant allele begin to show up more often in the population. At this point, a change has occurred. And that change is what evolution is in a nutshell. It doesn't get much simpler than that if you want to tie it up in a small box with a neat little bow. But Darwin and others were aware that things changed, but they had no idea as to the mechanism. Genes, or the discovery of genes, was still years away, and decades in fact. All they knew was that things changed. On top of this, breeders have been taking advantage of this for centuries. When breeders do this, when they select for the traits that they want to see perpetuated, they're the directors of the play. Natural selection is pushed aside when they take over, and Darwin himself bred rock pigeons to try his hand at it as well. And on the Origin of Species, he revealed his thoughts on the mechanism that worked with these changes in allele frequency to create the many forms and species around us. But, now there's always a but, isn't there? Natural selection isn't the only mechanism. Not only is natural selection not the same thing as evolution, but it isn't the only driver. There are other factors as well. We'll call them stagehands. They work behind the scenes, setting things up and altering props that can be reused from previous scenes. Now, one of these mechanisms I've already mentioned, genetic drift. It tells us that
some event precipitates getting an unrepresentative sample of a population.
Like a forest fire.
Of course, natural selection starts working on that.
Now, what about mutation?
Yeah, mutation, it's so fundamental that I think a lot of people forget that it too can just be a mechanism in and of itself.
Mutations happen all the time. When cells split, natural selection falls in love. It adores a good mutation to work with. Let's take frogs again, for example.
And you get an orange frog because there's a mutation in that gene which formed a new allele. All of a sudden, you've got an allele that's an orange allele.
And that orange allele may or may not provide a benefit to the frog's ability to cope in the environment it's in. If by chance it lives in a world of orange leaves, maybe it's autumn in Podville, then yeah, natural selection turns its amorous eyes in the frog's direction. Now, if the frog's orangeness hinders its ability to survive, if it sticks out like a sore thumb, well, natural selection loves that too. It's a deadly kind of love. But if that orange allele is neither a benefit nor a hindrance, well, then it's just along for the ride, and we'll see orange frogs gradually invade the population. So we've mentioned a couple of mechanisms at play here that work behind the scenes, those being genetic drift and mutations. Now, there's a third one, which we haven't mentioned, and that's
when individuals come and go from populations. They carry their genes with them, and that's going to disturb the allele frequencies.
And this is gene flow or migration.
If you go back to your population of frogs, if 50 newcomers come from the next town over, they've carried their genes with them, and assuming it's not in the same perfect distribution as the larger population, you've had a shift in the frequencies.
And that shift in frequencies can be subtle, or it can be noticeable. It's worth mentioning that these newcomers must breed with the original population for this shift to occur.
So gene flow, again, when individuals enter and leave various populations, and they carry their genes with them.
Yeah, they just wander in.
Carry my genes, wander out, take my genes with me. Another reason that teachers are most likely teaching this is because this is when gene flow, you really notice it when it stops. What happens is, if you sort of think of it as you have different colors of paint, and you're sitting there with your paintbrush and you're swirling them around constantly. So if you've been swirling that paint, you've been adding blue paint and adding red paint, constantly, and it's all swirling together into a nice, beautiful purple. And then if I stop swirling and keep adding paint, you start to see the differences.
And an amazing thing occurs when gene flow stops.
So when gene flow stops, you could actually say that that's the definition of a separate species.
A separate species when it comes to the most basic definition of a species. So with interbreeding, you're mixing colors. Eventually, the colors begin to separate, never to mix again. You can mix and mix until your arm gets tired, but what you have now are unmixable colors. So you see, natural selection isn't the only mechanism involved. And like stagehands in a play, they're often left off the program. Without them, though, there would be no play. The stage would be bare. The thing is, these other mechanisms are rarely ever mentioned when students are presented with or taught about evolution.
Most standards, unfortunately, don't cover any of these mechanisms except for natural selection.
And that's an incredible disservice if you're a mutation or the results of genetic drift and gene flow.
Educators have a real opportunity because, again, in some of the examples that they're probably already doing, these other mechanisms are in there, and it's just a matter of pointing them out.
And that opportunity can pop up in almost any example, like, say,
Darwin's Galapagos finches. And in that one story, which is, pretty much the, blue ribbon standard for teaching natural selection, you also get genetic drift, right? And of course, there's going to be mutation there as well. You could even say there's probably some gene flow in there as the birds were, leaving one population and settling in another island.
So there you have it. We have our production, that being evolution. We have our director in natural selection, and our many stagehands setting things up and tearing things down, such as mutations, genetic drift, and gene flow. It's quite a show, isn't it?
All the world's a stage, and all the men and women merely players. They have their exits and their entrances, and one man in his time plays many parts.
I want to thank Stephanie Keefe for her insight, her brilliance, and her help in producing this episode. You really should check out her work as well. You can find her articles in a number of places, but a perfect place to start is the NCSE blog at ncsc.com/blog. You can also reach out to Stephanie via Twitter at Keeps3. That's KEEPS3, the number 3. Now, I know I'm not wrong in saying that she'd love to hear from you and answer any questions you might have. And as always, you can help Evolution Talk grow by sharing the show. And if you want to help keep it chugging along, if you're a patron of the arts, please consider supporting the show at evolutiontalk.com/support. The music on today's episode was composed by two talented musicians, Kevin MacLeod and Chad Crouch. I'm Rick Coast, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.